Domestic switches are bearing very little current, nearly 5 to 15 amperes, but traction load switches like circuit breaker or interrupter carries no load current to full load current of around 0 to 1600 ampere, say. But during fault it carry a faulty current, say 4500 ampere for a little duration till auto trip or auto opening of circuit breaker. The domestic switches are operated manually by us, but in electric traction system this huge voltage and current cannot be handled manually. Instead of that, a DC 110 volt control circuit is used with current transformer and voltage transformer to reduce the current and voltage for the use of relays and meter. I have inquired about current transformer and potential transformer to young electrical engineers, but they are in dark about its function. What is current transformer? It is an instrument transformer used to reduce the secondary current to a rated load to 5 ampere, generally according to its ratio, say 500 by 5, means if primary current is 500 ampere, then secondary current is 5 ampere. But why? The operator cannot handle 500 ampere in the panel board, so the current is reduced with a small burden or load to work safe in the panel board where meter, relays, etc. are there. The burden is 100 volt ampere for electric traction purpose, means like a light load of 100 watt and safe to handle in the panel board. In 25 kV single phase traction supply system, mainly two types of load switch are used: circuit breaker and interrupter. Circuit breaker. It is a load switch which can be operated from no load to full load as well as faulty current. Circuit breaker is associated with other accessories like current transformer, potential transformer, relays to sense the normal situation as well as faulty situation, but during fault it will auto trip or open to make dead the faulty section. It can be operated locally or remotely, manually or electrically. Interrupter. It is a load switch which can be operated from no load to full load as well as faulty current, but during fault it will not auto trip but circuit breaker will trip. It simply works as a switch locally or remotely, manually or electrically. Figure shows the connection diagram of HV side overcurrent relay in the traction power supply system. When there is no earth fault in between CT1 and CT2 two power transformer, the current will flow through CT1, OCR1, ammeter, CT2, then to CT1, and no current will enter in the earth fault relay. We have seen the current flow from grid supply system to the traction substation in the primary side of the power transformer. Now we'll see the current flow in the CT secondary . When this current is more than the relay setting value of OCR, then OCR relay will energize. Now we'll see when there is a earth fault between CT and power transformer, how earth fault relay acts. Due to earth fault, there is a current difference in red phase and blue phase. Hence, the current difference in CT1 and CT2 also.